Hello everyone, welcome to GATE Academy Global, and today we are going to discuss a very important subject of civil engineering, that is transportation engineering. So we are going to discuss how transportation engineering is bifurcated and what are the weightage that are going to come in other very different examinations like GATE, EAC, SSC, JEE, RRB and many more. So we are going to see how transportation engineering is bifurcated. So let's see, the transportation engineering is bifurcated into three important parts, that is, first is highway engineering. First is highway engineering. Second part in which the transportation engineering is bifurcated is railway engineering. And the third part is airport engineering. Okay, these are the three parts in which the transportation engineering, whole transportation engineering is bifurcated. If we talk about the weightage of these bifurcations part, the highway engineering carry the maximum weightage in any of the examination in which you are going to fight. So the highway engineering carry the maximum weightage. So we'll go for the topic which carry maximum weightage. So we are going to start with highway engineering, like how highway engineering we are going to deal and what are the points or what are the syllabus we are going to discuss in highway engineering. So let's see how highway engineering or how we are going to study highway engineering. So highway engineering syllabus is divided like how we are going to study is highway engineering. In first step we are going to discuss about geometrical design. First part we are going to discuss about geometrical design. In second part we are going to discuss about, after geometrical design we are going to discuss about traffic engineering. We are going to discuss about traffic engineering. Third part we are going to discuss in highway engineering is highway material. And the last point we are going to discuss is pavement design. As I told you, highway engineering carry maximum weightage in whole transportation engineering, and if we talk about GATE 2019 examination, we will come to know the around 11 marks question are come from transportation engineering in GATE 2019, and around in set 1 in GATE 2019 set 1 in paper 1, and in evening shift it is carrying around 9 marks in GATE 2019 examination. So we are going to discuss we are going to discuss highway engineering, and in highway engineering we bifurcated our subject in our syllabus in this 4 important parts. Out of these 4 parts, geometrical design and traffic engineering is one of the most important part of highway engineering syllabus. So we are going to discuss these 2 topics, geometrical design and traffic engineering, in very depth. Now when we start with geometrical design, we'll come to know how geometrical design is bifurcated. So geometrical design is bifurcated like, so first let's start with geometrical design. In geometrical design, it is bifurcated in 4 parts. The first part is pavement characteristics. Okay, fine. If we discuss about geometrical design, we can say that geometrical design, if we are going to discuss about geometrical design, we can say the geometrical design are those parameters which can be easily visible to us, or which are the features which can be sensed. Okay, so we can say the geometrical design, first we are going to discuss about pavement characteristics. So the pavement characteristics, the definition which are going to come under pavement characteristics are like friction, like skid and slip, like unevenness, like light reflection characteristics. All these are the features which we can see, or which we can analysis, or which we can see, which we can sense. These are the characteristics comes under the pavement characteristics. The second point we are going to discuss in geometrical design is sight distance consideration. In side distance consideration, we are going to bifurcate it into three important terms. The first one is stopping side distance, we can call it as SSD. The second one is OSD, overtaking side distance, and the third one is intermediate side distance. We are going to study them. Very thoroughly once we have seen what are the chapters that are coming in geometrical design. So after that, we can say this, after side distance, the third part in which the geometrical design is bifurcated is horizontal alignment. Horizontal alignment. In horizontal alignment, the important terms which we are going to discuss is, first is super elevation. The second part we are going to discuss about is setback distance. Third important term of horizontal alignment is transition curve. These are few important definitions which we are going to study under horizontal alignment. And the third part and the last part which we are going to discuss in geometrical alignment is, fourth is geometrical design, is vertical alignment. In vertical alignment, we'll bifurcate into two portions. First is valley curve, and the second one is sag curve. So we are going to discuss, first we are going to discuss about highway engineering, and in highway engineering, the first topic which we are going to discuss about is geometrical design. So as I told you, geometrical design is bifurcated into four important parts. First is pavement characteristics. All those characteristics which we can, the physical features which we can analyze are come under the pavement characteristics. So whatever the definition coming under the pavement characteristics, we'll go to discuss we'll discuss further in SSD, OSD and upcoming parts, but we are not going to start with the pavement characteristics because it is quite theoretical portion and it carries marks of around 1 to 2 weightage. It carries a weightage of around 1 marks in examination. So whatever the definitions coming under the pavement characteristics, we are going to discuss in further video lectures in between our whenever they are come in use, we will discuss them. So first we'll start our discussion with the side distance consideration. So what is side distance consideration we are going to discuss, and these side distance are bifurcated in three portions, that is stopping side distance, overtaking side distance and intermediate side distance. So we are going to start with the term called as stopping side distance. So now let's start with the term side distance consideration. In side distance consideration, the first term which we are going to study is stopping side distance. So we are going to study about stopping side distance, or we can also call it as non-passing side distance. So from the term non-passing side distance, we can directly say as the term representing that the distance is not sufficient enough to overtake the vehicle which is moving in front of the test vehicle. The test vehicle, we can call it a test vehicle in which we are moving. So we can say the distance is not sufficient enough to overtake the vehicle moving with a slow speed. Fine. So we can start with the term stopping side distance. We can say the stopping side distance is the distance, or let's start with the definition. We can say the definition of stopping side distance is, it is the minimum distance, visible ahead to the driver, from a specific height above the carriageway, from a specific height above the carriageway to avoid collision, or to stop the vehicle just before the collision. So we, from the definition, we will come to know, as we are going to make some figure for it, we can say, as per the definition, we can say there is a vehicle moving on this road, on this pavement, with a velocity v, with a velocity capital V. A vehicle is moving with a velocity v. There is a driver sitting over there with a specific height. We are considering that the driver having a specific height above the carriageway. So the specific height we are considering is the height of driver I, and as per IRC, the value of this driver height is given as 1.2 meter. Is given as 1.2 meter, with which the driver is seeing the object which is coming in front of it. If we discuss about the object which is going to seen by driver, is of, it should be greater than 0.15 meter. 0.15 meter. Why we are calling it should be greater than 0.15 meter? Because we will come to know, if it is less than 0.15 meter, it won't get your vehicle or your driver won't get affected by this obstacle, or we can say it is not going to affect your vehicle. So the height should be such that it is going to affect your vehicle. So we are considering that it should be greater than 0.15 meter. If we say, let's take an example, we can say this marker is falling on your road on which we are moving. So we can say this marker is not going to affect your vehicle on the on whatever the road you are moving. This marker will not going to affect your vehicle. So we can say the height should be 15 centimeter. The height should be 0.15 meter, or should be more than that. So it will affect your vehicle. So we are saying, as per the definition, we are saying it is the minimum distance visible ahead to the driver. So we are taking the driver is moving with a velocity v, and the vehicle is moving with a velocity v, in which the height of driver I is 1.2 meter. At any instant, the driver sees an object of around greater than or equal to 0.15 meter and applies the brake. At the sudden instance, when he sees an object and apply the brake, so the minimum distance which is required by the vehicle to stop just before the collision, the minimum distance which is required by the vehicle to stop just before the collision is termed as stopping side distance. Now we can say that the stopping side distance is the combination of, so we can say that stopping side distance is the combination of two terms, that is lag distance plus braking distance. Stopping side distance is the combination of lag distance plus braking distance. So we can say, let's discuss with the definition first, what lag distance is, what braking distance is, and how we are going to find the stopping side distance. So we can say that the lag distance, if we talk about the definition of lag distance, we can say it is the minimum distance, or lag distance is the distance covered by the vehicle. Let's hear it. Lag distance is the distance covered by the vehicle in total reaction time. Distance covered by the vehicle in total reaction time. Now there is one new term coming in front of you as total reaction time. What total reaction time is? So I can say the total reaction time is the time taken from an instance driver sees an object and the instance he applied the brake. The time taken from the instance he or she sees an object and the instance he applies the brake. The moment or the time taken in between these instances, the moment he sees a vehicle and apply the brake, the total time taken in between this instance is termed as total reaction time. So we can say that the total reaction time, so by lag distance, by the definition we can say that our vehicle is moving with a capital velocity v, or we can say that it is moving with a velocity v meter per second, and the total reaction time that is going to come is we are going to describe it by small t, or we are going to define it by small t. So we can say the lag distance is equal to v cross t. What about this total reaction time and how it can be find? So as per PIEV theory, This time t is given as 0.5, vary from 0.5 to 3 to 4 seconds. 0.5 to 3 to 4 seconds, but generally as per IRC, this value for stopping side distance is given as 2.5 seconds. This value is given as 2.5 seconds. So if in examination you are going, like if small t is not given or if total reaction time is not given, we are going to consider it as 2.5 seconds. Fine. So the lag distance is equal to V cross t. Now we are going to discuss what braking distance is. So the moment, as I told, the lag distance is the total distance covered by the vehicle in total reaction time. It means once you seize an object and apply the brake. So we are talking about, we are considering it like this. At this moment, the vehicle, when the vehicle is moving with velocity v, our driver sees an object and applies the brake. So from here to here, these are the two positions, from position 1 to position 2. Position 1 is the position our driver sees an object. Position 1 is the position, we are saying it as 2. So position 1 is the position when the driver sees an object and think of applying the brake and suddenly applied the brake. Position 1 is the position from where a driver sees an object and think of applying the brake and he applied the brake. So the distance covered in between this process is this distance, and this distance is termed as lag, and distance is termed as lag distance. Distance covered in this total reaction time is lag distance. Now as he applied the brake, now our vehicle takes some time or will take some distance to stop before the collision. So the distance covered, by the vehicle in this brake reaction after applying the brake. So the distance covered by the vehicle after applying the brake is termed as braking distance. So we are calling it as braking distance. This distance we are calling it as braking distance. Braking distance. As we already find how lag distance is going to calculate it, now we are going to see how braking distance is going to get calculated. First, before this, we are going to discuss how total reaction is calculated. As I told you, total reaction time, if we discuss about total reaction time, we further discuss about total reaction time. This total reaction time can be calculated by two methods. First is, here it is PIEV theory, and here this total reaction time is divided into two portions. First is perception time, and second is brake reaction time. It means the total reaction time is the combination of perception time and brake reaction time. Now individually we will discuss what perception time is and what brake reaction time is. So we can say the perception time is the time taken by the driver from an instance he sees an object and think of applying the brake. Listen once again. I am going to repeat the definition of perception time. As I told you, perception time is the time taken by the driver from an instance he sees an object and think of applying the brake. It means the moment our driver sees an object and think of applying the brake is called as perception time, or the time lost from the moment he sees an object and think of applying the brake is perception time. And the moment he effectively applied the brake, it means we are telling that our perception time is the time when he sees an object and think of applying the brake or sending the message to the brain to apply the brake. And the moment our brain reacted and effectively applied the brake, the time taken in this total process is brake reaction time. The moment our brain get this perception that there is some object in front of us and we effectively applied the brake. After getting a signal from the brain and we effectively applied the brake, this brake is called as, time is called as brake reaction time. Fine. So we are going to see how like brake reaction time or the braking distance is being calculated. So our next point of discussion is how braking distance is calculated. So we can say the braking distance is the distance covered by braking distance is the distance covered by the vehicle after effectively the brakes are applied. So we can say braking distance, we are going to discuss about braking distance. Fine. So I'm telling you, in braking distance we are learning from this figure. Let's see this figure. I'm telling you, there is a vehicle, from the moment the brake is applied, the brake is just going to be applied, the vehicle is moving with a velocity v. The moment the brake is applied and the distance covered by this vehicle to come to stop position, is equal to v is equal to come to stop position, or we can say to the velocity, to the final velocity equal to 0. So the distance covered from this to this, from this first phase to second phase is termed as braking distance. And we can say that your whole kinetic energy is converted into work done. We can say we are going to apply here work energy principle. So we are going to see the phase 1, or we can say at an instance of 1 and 2, we are going to discuss about these two situations. We are considering the coefficient of friction as mu, or we can say we are considering the coefficient of friction as F. So let's see how work energy principle is being applied. So we can say by work energy principle. We are going to say it by work energy principle. Let's see how work energy principle is applied. Work energy principle. Let's see how work energy principle is applied. So we are considering first our kinetic energy, change in kinetic energy. We are going to say it as change in kinetic energy is equal to work done. The total work done is equal to total work done. How, let's see at phase 1 and phase 2, the kinetic energy at phase 1 at an instance of 1 is half mv square, the velocity with which our vehicle is moving, and m is the mass of the vehicle. Fine. We are considering at position 2, the velocity, the kinetic energy equal to half m v square, and the velocity is equal to 0. So we can say that the change in kinetic energy is equal to half m v square. Let's talk about work done. So work done is your total kinetic energy is converted into work done, and work done is done by only by frictional force. So we can considering it as capital F. Let's discuss about frictional force that is going to be applied on our vehicle. Frictional force. What are the frictional force that is going to be applied on our vehicle is, let's discuss, we are giving it a name capital F, and the frictional force is equal to mu, or we can say the coefficient of friction acting on our vehicle, we can call it as small f, and the total normal reaction which is going to be applied on our vehicle, it is equal to m into g. That frictional force is equal to F into m into g. And if we talk about the work done, so the total distance covered in this portion, I'm giving it as a name L. I'm getting braking distance is equal to L. So we can say the change in kinetic energy is equal to work done, and work done is equal to frictional force multiplied by the distance covered in this process. So we can say it is equal to capital F multiplied by L. So by putting the value of F, we'll come to know that F into m into g into L. So we can cancel out mass from mass. So we come to know about the value of braking distance. This is this capital L is the value of braking distance, and we'll finally get the expression L is equal to V square by 2gf. This is the braking distance we are going to get from this work energy principle. So we can say, if we talk about the total stopping side distance which we are getting from these two expressions, lag distance and braking distance, we can say that the final expression for calculating the stopping side distance is SSD is equal to lag distance plus braking lag distance plus braking distance. And what is lag distance here? The value of lag distance is small v into t. This v is the velocity with which our vehicle is moving, and it should be in meter per second. And here is the time IRC as per given by IRC is 2.5 seconds. Plus, if we talk about the braking distance, so the braking distance is given as v square divided by 2gf. Here v is the velocity, we can consider it as in meter per second, and f is the coefficient of friction, coefficient of friction. Now if somebody asks you what this coefficient of friction is, like what is the value you are going to calculate, you are going to consider for the value for the coefficient of friction f. So let's discuss about the friction. As I already told you, we are going to discuss our pavement characteristic in between these topics which we are going to discuss in deep. So first we are taking one important consideration or one important point or one important definition from pavement characteristic, that is friction. Now let's discuss about friction, what friction is and how the value is calculated, or what is the value can be computed, or what is the value can be considered. And as per IRC, what are the longitudinal friction value, what are the lateral friction value, and what is longitudinal friction and what is lateral friction. So we can say that if we talk about friction, the friction is the friction always acts in opposite to the direction of motion. We know this basic definition, that friction is always acts in the opposite to the direction of motion. So we can say here we can see our vehicle is moving in a straight path in longitudinal direction. If we talk about the axis of this road or this pavement, we can say that our vehicle is moving in a longitudinal direction. Now we'll see what longitudinal is, what lateral is. So we are telling that consider it as a pavement, we are moving on this pavement. So the long axis of this pavement is considered as longitudinal axis, and the transverse axis or the axis perpendicular to the long axis is considered as transverse axis. So we are telling that when the friction is acting in the direction in opposite to the direction of motion, but it should be in the direction of longitudinal axis, then it is called as longitudinal friction. And the friction, when our vehicle is moving in lateral direction and the friction is acting on lateral axis, we can call it as lateral friction. But the lateral friction will not come in picture, will not come in role until and unless our vehicle is moving on a horizontal curve. When our vehicles start moving on a horizontal curve, then we see a horizontal force called as centrifugal force. Then centrifugal force start acting on our vehicle, and it will try to take our vehicle away from or out of the carriageway. So the friction will help our vehicle to come in to move on a carriageway. So we can say that the friction that is acting when the vehicle is moving on a horizontal curve is lateral friction. But right now the friction which we are going to consider in this braking distance is friction, the value of this friction, or we can say that this friction is longitudinal friction. We are going to say it is the value of longitudinal friction. It is the value of longitudinal friction. So we can say the total value which we are going to calculate for SSD is Vt plus V square by 2gf. This is the expression from which we can calculate the stopping side distance. Now we can raise the bar a little bit further for other examination, like for engineering services examination or for gate examination. This is the simple value which is going to be asked in SSC JE or by in RRB examination. But if we raise a bar a bit, we can say, let's compare it with let's see what we are going to do. We are taking it as, we are considering the Newton's equation for motion. Newton's equation for motion. So we are telling that your final velocity V square is equal to U square plus 2as. This is the Newton's equation of motion. We can say that the final velocity V square is equal to U square plus 2s. The final velocity which is going to come from this outcome as 0. So we can say that our next expression would be U square is equal to minus 2as. but this minus sign is representing retardation here, as we are applying the retardation because we are applying the brake over the pavement surface. So this minus sign is representing the retardation value. So we can also write it as u square is equal to 2as. If we write it further, we can say that s is equal to, s is the distance covered when the brake is applied and your final velocity is going to be 0. So this s is the side distance, or we can say that braking distance. So this s is equal to u square divided by 2a. This s is equal to u square by 2a. We are giving it as term, we are giving it a name 2, the equation number 2 for us, and this is the equation. We are giving it a name for this, not for this, for braking distance, we are giving it a name called equation number 1. Now on comparing equation 1 and 2, we will come to know that for first our equation number 1 is L is equal to V square divided by 2GF, and our equation number 2 is S is equal to U square divided by 2A. So on comparing equation number 1 and equation number 2, on comparing equation 1 and equation 2, we'll come to know that the value of A is equal to GF. The final value of A should be equal to value GF. Here small g is representing the acceleration due to gravity and F is representing the value of longitudinal friction. If we discuss about the value of longitudinal friction, what is the value for longitudinal friction that should be considered? So we can say that as per IRC, the value of longitudinal friction should lie between 0.35 to 0.4. The value of friction should lie between 0.35 to 0.4. So if anybody asks you what is the value of friction, or we can say from what limit to what limit the friction value will exist, so we can say that the value of friction should lie between 0.35 to 0.4. This is the simple question which is going to be asked in some basic examination like SSC, JEE or RRB. What gate is going to be asked, what is going to be asked in gate or engineering services is from where the value of A should lie. And we can calculate it very easily. The value of A should lie from, what we have to do is we have to multiply G in all of them. So we can say that let's see this, F into G we can call it as A. The value from, if we multiply G, 9.81 value in 0.35 will get 3.43, and if we multiply 9.81 in 0.4 we get the value 3.93. So if we say, if it asks what is the value of A should lie, like what are the ranges of A, what are the value of acceleration, or we can say the retardation for longitudinal friction is lies between 3.4 to 3.93. This is the question which is already asked in gate, and we can compare it very easily from the Newton's equation for motion. So let's see. So we can till now we discussed how our stopping side distance is being calculated on flat gradient. Now we see in next video we are going to see how what are the variations are going to come in stopping side distance if we move our vehicle on up gradient or some down gradient. Here there is no change, we considered no change in gradient. We are taking it as a flat gradient on which our vehicle is moving. So let's see in our next video how it is going to affect and what are the values that is going to become, or what are the expression, what are the change in expression that is going to come if we are considering our vehicle to be moving on up gradient or some down gradient. Thank you.